Have you ever stopped to think about what's actually happening behind the scenes when you're scrolling through Airbnb? You've got millions of homes, millions of hosts, millions of travelers, all in one app. Well, today we're going to pull back the curtain on the incredible, complex engineering that makes it all possible.
And to kick things off, just try to get your head around this number. Over 1,000 engineers, 1,000 people contributing code to the same platform. So the big question is, how do you manage that kind of scale without the whole thing just collapsing in on itself? That's what we're here to figure out.
All right, so here's our game plan. We're going to start at the beginning with their single, massive code base and see why they had to tear it apart. Then we'll dive into the absolute genius behind their search results, the bulletproof system they use for bookings, and how they make the app feel so slick. And we'll wrap it all up with the core blueprints that hold the entire empire together.
So every huge tech company has an origin story, right? For Airbnb, it all started with a single, giant application that did, well, everything. And for a while it worked. But as they got bigger and bigger, that simple solution started to show some really serious cracks.
They actually had a name for it, the monorail. And honestly, the best way to think about it is like a giant Jenga tower. You know, when you first build it, it's simple, it's stable. But as you keep adding more blocks, more features, more engineers working on it, the whole thing gets incredibly fragile. One wrong move in one tiny part of the code could bring the entire site crashing down.
And the pain points were very, very real. Pushing a simple update could take hours. Engineers were constantly stepping on each other's toes in the code. A tiny bug in, say, the photo uploading feature could literally take down the entire booking system. The blast radius, as they called it, for any mistake was 100%. It wasn't just slow, it was becoming a massive risk to the business.
So what do? You break it up. They made the tough decision to move away from the monorail and rebuild everything as thousands of tiny, independent microservices. So you'd have one for payments, one for messaging, one for reviews. You get the idea. But like always in engineering, solving one huge problem just created a completely new and very complicated one.
And that new problem had a pretty great name, Spaghetti SOA. SOA stands for Service-Oriented Architecture. With thousands of these little services all needing to talk to each other, the system turned into this chaotic, tangled mess. Just trying to follow a single user's request through that web of connections was an absolute nightmare.
Their solution to this was brilliant. It's a system they built called Viaduct. Now the difference here is subtle but so important. A traditional system, a service mesh, basically just worries about the plumbing, how the services connect. But Viaduct is different. It's data-oriented. It cares about what the services are saying to each other. It understands the data, its structure, its dependencies. It's less like a plumber and more like a master librarian for the entire system, knowing where every piece of information belongs.
Okay, let's switch gears and talk about something we've all experienced, the search. Searching on Airbnb is a uniquely difficult problem. I mean, think about it. You're not just looking for a product with a model number. You're looking for an experience, a feeling, a vibe. Exactly. How on earth do you program a computer to understand the vibe of a romantic getaway? A simple keyword search just falls flat. Because that romantic getaway could be a log cabin in the woods, a treehouse, or a slick apartment in the city. The raw features of the listing don't really capture the essence of what you're searching for.
And this is their incredible solution. It's a machine learning model they call a two-tower architecture. It's basically a matchmaking service. One AI, the listing tower, looks at every single detail of a home, photos, reviews, amenities, and boils it all down to a unique mathematical signature. We can call that its vibe vector. Then, a second AI, the query tower, does the same thing for you based on your search, and the magic happens when the system finds the homes whose vibe vector is the closest mathematical match to yours.
Now, when it comes to the map view, something as simple as the shape of the grid you use makes a huge difference. Airbnb uses Uber's H3 system, which uses hexagons, instead of Google's S2 system, which uses squares. Why? Well, look at the slide. For any hexagon, all of its neighbors are the exact same distance away. This is a game changer for calculating things like the average price in a neighborhood because you don't get those weird distortions you get from the faraway corners of squares.
All right, we've found the perfect spot, and now it's time to book it. We are now entering the absolute heart of the system, the transactional core. And in here, there is zero, and I mean zero, room for error.
Because think about it, a double booking isn't just a bug. It's a vacation-ruining, trust-destroying catastrophe. Imagine flying across the world, showing up to your rental, and finding another family already inside. It's a nightmare.
So the booking system has to be perfect 100% of the time. Correctness is totally non-negotiable.
To guarantee this perfection, they built a system called Orpheus. And it's so clever, it works in 3 super strict phases to make sure you never ever get charged twice, even if your Wi-Fi cuts out mid-payment. First, and notice the constraints, it locks your request in their database. No slow network calls allowed. Second, it makes the payment call to, say, your credit card company. And during that phase, it does nothing else. No database changes. Finally, once it gets a clear yes or no, it records that final result back in the database. That clean separation of concerns is what makes the whole thing bulletproof.
Okay, so the back end is an absolute fortress. It's robust, it's reliable. But how does Airbnb translate all this insane complexity into that smooth, seamless experience you have on your phone?
Well, let's take a look at pricing. Instead of using some mysterious black box AI, they built a tool called AeroSolve. They call it machine learning for humans. And what's so cool here is that it doesn't just give a host a price, it explains why. It'll literally say, hey, because you have a pool, we suggest adding 15%. This kind of transparency is huge. It builds trust and makes the host feel like a partner with the technology, not just a subject of it.
And this might be the most magical part of all: server-driven UI. In a normal app, the server just sends raw data, and your phone has to figure out how to build the screen. Airbnb's system, called the Ghost Platform, is totally different. The server doesn't just send data, it sends the entire recipe for the screen. It tells your phone, put a big photo here, a carousel of reviews here, and a Book Now button right there. This is the secret to how they can completely change the layout of the app without you ever having to go to the App Store and download an update. It's amazing.
So, after that whirlwind tour through Airbnb's tech stack, what are the big ideas? What are the fundamental blueprints we can learn from this incredible architectural journey?
It really boils down to these 4 core principles. First, a schema-first design. That means you define your data structures first, because that is the architecture. Second, use specialized tools for specialized jobs. Don't try to make one database do everything. Third, when it comes to money, correctness is always more important than speed, period. And finally, if an AI is making decisions that impact people's lives and livelihoods, those people need to be able to understand how it works.
Which really leaves us with one final big question to think about. As we move forward and build the next generation of platforms that are all built on trust between total strangers, which one of these principles do you think is the most important? Is it the bulletproof financial system? The transparent AI? It's a huge question, and one that the next wave of founders and engineers will have to answer.